On August 15, 2018, Trello's server load jumped from 42% to 98% in 3 minutes, and the entire company effectively shut down. Within 5 minutes, 2.3 million active users, 35% of which were Fortune 500 companies, couldn't access their workboards at all. This wasn't just an outage, it was a crisis that needed to be fixed fast before this one server outage collapsed the entire company. From the outside in, though, this existential panic was not surprising at all. Trello's infrastructure was outdated. Built in 2011 using traditional server architecture, it initially only needed to handle 500,000 users, and since their selling point was real-time collaboration, they just kept their servers on 24/7. This approach worked really well when Trello served 70,000 requests per hour, not so much when you're handling 4.5 million requests an hour. And it wasn't like people didn't know. Months before this disaster happened, Trello's lead infrastructure engineer, Sarah Chen, said that they were spending $3.2 million annually on AWS just to keep servers running at 30% capacity. For comparison, competitor Monday.com served similar traffic while spending almost half that amount. But the infrastructure problems weren't just financial. Real-time collaboration, Trello's core feature, demanded instant updates. When a user moves a card on a board, everyone needs to see that change immediately. By 2018, it took Trello 2.3 seconds to show a change made by a user to its boards. Meanwhile, Slack was maintaining 200 millisecond averages. All this meant that by August of that year, Trello's problems became impossible to ignore. For most of the corporations relying on Trello for critical project management, every system hiccup meant missed deadlines and inefficiency in the workflow. The companies weren't happy. User complaints doubled monthly as simple actions like moving a task card took 5 seconds, with people in Asia having to wait up to 8 seconds to see an update on their board. All this is to say that something had to change. And change it did. Speaking of, thanks so much for all the support on the channel lately. It really means a lot, and I want to give something back to you guys. So do you need a job? That sounded a bit weird. But whether you're a UX designer, app developer, freelancer, or just a curious viewer, I want to get to know you guys, share some UX and UI tips, and maybe even get a gig. So I made a Discord channel for us and want to make this the place to be for front-end professionals. And I'm having talks with people to get some employers in there so you can connect with them too and find some jobs in the future. I'm really excited to get this thing started, so I hope you'll join me. Kubernetes. What the heck is Kubernetes? Think of Kubernetes like a smart city traffic control system. Just as a traffic system manages thousands of vehicles efficiently, Kubernetes manages containers or individual applications running across multiple servers. The problem it solves? Before Kubernetes, companies ran applications like Trello on dedicated servers. Imagine having one highway for each type of vehicle. When traffic, or user demand, increased, they had to build new highways or add servers, which was expensive and inefficient. During off-peak hours, these highways sat empty, wasting resources. Before Kubernetes, Trello's monolithic architecture ran on EC2 instances that each required full 8 gigabit RAM allocation, even when using only 2.4 gigabytes on average. Think of it like renting an entire office building but only using one floor. Inefficient and expensive. These instances hosted everything from the Node.js application to MongoDB connections and WebSocket handlers. It's similar to having all your company's departments crammed into one building. When the sales team needs more space, you have to rent another entire building, even if marketing has empty desks. During traffic spikes, AWS autoscaling groups took 8 to 12 minutes to provision new instances, configure networking, and join the load balancer pool. An eternity when handling real-time collaboration. For users, this meant staring at loading screens while Trello scrambled to add capacity, like waiting for a new restaurant location to open because the current one is full. Kubernetes transformed this through container-based microservices, breaking the monolith into 200-plus independently scalable services. Each service, packed in containers as small as 100 megabytes, could be deployed, scaled, and updated independently. This granular approach meant Trello could scale specific components, like the card update service during peak usage, without wasting resources on less used features. When it came to managing traffic and system resources, Trello introduced something called the Horizontal Pod Autoscaler. Think of it as an intelligent traffic controller for their entire system. This automated manager monitored everything from CPU usage to memory consumption in real time, making split-second decisions about when to add or remove computing power. When any part of the system showed strain, like CPU usage hitting 70%, it automatically created new containers to handle the load. But what made it truly remarkable was its predictive capabilities. Using historical data and machine learning, it could anticipate busy periods before they happened. For example, knowing that Monday mornings typically saw 3 times normal traffic, it would start preparing extra capacity around 8 a.m., ensuring users never experienced slowdowns during their busiest times. Resource optimization reached new levels through Kubernetes bin packaging algorithms. These algorithms intelligently placed containers across the cluster, ensuring maximum resource utilization. When a node or server failed, Kubernetes automatically rescheduled affected containers to healthy nodes in seconds. CPU throttling and memory limits were enforced at the container level, preventing any single service from affecting others. The results were dramatic. During traffic spikes, Kubernetes could spawn 50 new containers across multiple availability zones in under 30 seconds. Resource utilization jumped from 30% to 77% through precise allocation. Most importantly, the system could now handle traffic surges without the 8-minute scaling delays that previously disrupted user experience. While competitors like Asana and Monday.com took minutes to adjust to traffic changes, Kubernetes could scale Trello's capacity in seconds. For users, this meant no more waiting for boards to load during Monday morning rushes or team meetings. But implementing Kubernetes wasn't like flipping a switch. It was more like performing heart surgery while the patient runs a marathon. The mitigation presented technical challenges unprecedented in Trello's history. The sheer scale was staggering. The team faced migrating a 12-terabyte MongoDB cluster containing 500 million cards and 1 billion activity logs, all while maintaining real-time synchronization across their WebSocket infrastructure, handling 2.3 million concurrent connections. Imagine moving an entire city's population without anyone noticing they've been relocated. The biggest headache? Keeping everyone's data in sync during the move. Imagine trying to update a shared Google Doc while someone's moving it to a different folder. Now multiply that complexity by millions of users making changes simultaneously. The numbers reveal the magnitude of this challenge. Trello's database was handling 4,500 queries every second, with changes taking up to 15 seconds to sync across all servers. Traditional migration methods would have frozen updates for 30 seconds at a time, an eternity for teams relying on real-time collaboration. It's like telling millions of people to stop working mid-task while you move their files to a new office. To solve this, the team had to develop a custom migration system using advanced data capture and dual write mechanisms, essentially creating a way to update both old and new systems simultaneously until the migration was complete. The team developed an ingenious solution, though explaining it requires a brief dive into some technical details. Their solution implemented a Kafka-based event streaming pipeline that captured database changes in real time. This allowed them to maintain 2 parallel systems, the legacy MongoDB clusters and the new Kubernetes-managed stateful sets, while ensuring data consistency through a distributed transaction coordinator. The custom migration tool used atomic batch operations and incremental state transfers, reducing transition freezes from 30 seconds to 50 milliseconds. In simpler terms, they built a system that could mirror changes between old and new databases instantly, like having a perfect real-time backup of everything. The WebSocket migration was equally complex. With 100,000 card movements per hour generating real-time events, they couldn't afford any synchronization delays. They implemented a blue-green deployment strategy with a custom socket.io clustering solution that could handle connection handoffs between old and new infrastructure without dropping existing connections. This required building a distributed session store using Redis clusters for connection state management and implementing a custom protocol for graceful connection migration. To put this achievement in perspective, when Asana attempted a similar migration, their approach caused 72 hours of sync issues due to replication lag and connection drops. Trello's technical solution achieved a sub-100 milliseconds failover time with zero data loss, maintaining real-time collaboration throughout the migration. The results were transformative, going far beyond the promised 40% cost reduction. The most critical improvement came in database performance, reducing sync delays from 15 seconds to under 100 milliseconds. To put this in perspective, while users previously waited the length of a TV commercial to see their teammates' changes, the new system would be faster than a human blink. This meant real-time collaboration would finally be truly real-time. The system's ability to handle WebSocket connections would become virtually unlimited, breaking free from the 2.3 million concurrent user ceiling that forced periodic restarts. Memory utilization would jump from an inefficient 30% to over 75%, like upgrading from a half-empty office building to one running at full capacity. Perhaps most importantly for daily operations, system updates could be rolled out seamlessly without the dreaded "Trello is down for maintenance" messages. For the millions of users depending on Trello daily, these technical improvements translated into tangible benefits. Boards would load instantly rather than forcing users to wait 5 to 6 seconds, a delay that studies showed caused 30% of users to switch tasks while waiting. Team collaboration would become truly synchronized, eliminating the confusion of different members seeing different versions of the same board. The persistent timeout errors that plagued Monday morning meetings would disappear, and new features could be deployed daily instead of weekly, keeping Trello competitive with rapidly evolving competitors like Asana and Monday.com. So how did this transition translate into numbers? Kubernetes transformed Trello's performance across every metric. Server costs dropped by 35%, $112,000 monthly savings, while utilization improved from 30% to 77%. Global response times plummeted. European users saw speeds increase from 5 seconds to 200 milliseconds, outpacing competitors Reich at 350 milliseconds and Notion at 280 milliseconds. The new infrastructure enabled rapid scaling and development. Instead of bi-weekly updates, Trello now deploys 15 to 20 times daily, matching Netflix's pace with 99.99% reliability. Mobile performance improved dramatically. Crash rates fell from 4.2% to 0.3%, boosting the Android app rating from 4.1 to 4.6 stars. The real test came during COVID-19. When daily users doubled from 2.3 to 4.7 million in 3 weeks, costs only increased 15%, while competitor Monday.com's similar growth triggered a 70% cost spike. Today, Trello handles 8.5 billion monthly API requests with 120 millisecond response times, 50% faster than industry average at 40% lower infrastructure costs. Not only that, it opened the door to new possibilities. Trello's Kubernetes transformation opened new possibilities for global expansion. The platform now automatically deploys servers in regions with growing traffic, cutting latency by 85% in emerging markets like Brazil and India. When regional traffic spikes occur, like during European business hours, resources shift automatically without requiring engineer intervention. The team conquered several technical hurdles along the way. They developed a custom load prediction algorithm that anticipates traffic spikes 30 minutes in advance, allowing servers to scale up before they're needed. This system now handles traffic surges 6 times more efficiently than their old manual scaling. Security improved unexpectedly. The containerized architecture means potential breaches can be isolated and resolved without affecting the entire system. In 2022, when a critical vulnerability was detected, Trello patched it across all regions in 7 minutes, compared to the industry average of 4 hours. The mobile experience saw dramatic improvements. The app now syncs data 5 times faster while using 40% less battery power. Push notifications arrive within 100 milliseconds globally, faster than WhatsApp at 150 milliseconds and Slack at 120 milliseconds. These improvements helped Trello grow from 35 million to 80 million users in 18 months, while maintaining the same infrastructure budget. If you liked this video, we recommend you to watch how ChatGPT became a $157 billion giant in just 14 months.